We have another example on the board. Let's take a look what we're supposed to find. We're supposed to find voltage source. Okay? Let's take a look what we have given. We have given I1. Okay? I1 is equal also to I total. Okay? Because this is the current which is going out from the voltage source. Okay? This is the main current which goes out from the voltage source. So this is I total. And because it goes through resistor R1 is also called I1. That's why I can say that I total is equal to I1, and in our case this is equal 10 milliamps. We have to find a voltage source. Please also notice that R total is given. So if you are going to use Ohm's law, you're supposed to write the voltage source is equal I total times R total, where I total is equal 10 milliamps times R total 20 kiloohms. Everything is equal 200 volts. Okay, so this is the voltage source in my circuit. Okay, this is the value of the voltage source in my circuit. So next, we're supposed to find the total resistance of these two resistors. Please notice that these two resistors are in parallel. Okay, so if I have two resistors in parallel, I can use the formula called product over the sum. So I have R23 is equal R2 times R3 over R2 plus R3. This is equal 900 ohms times 1.5 kiloohms over 900 ohms plus 1.5 kiloohms. Everything is equal 562.5 ohms. Okay, so this is the total resistance of these two resistors together. Now we can redraw the circuit, and our circuit is going to look like this. We have R1 and we have resistor R2, 3. Please notice that we obtained the series circuit. So what does it mean? It means that we can use the formula which says R total is equal R1 plus R2, 3. We have given R total. We just found R2, 3, so very easy we can find R1. If you are going to solve this formula for R1, you will obtain R1 equals R total minus R2, 3. Okay, so I can say that R total is equal 20 kilo minus R2, 3, which is equal 562.5 ohms. Everything is equal 19.43 kilo. Okay, so this is the value of the resistor, right? R1. So far we found the voltage source and we found also the resistance R1. Okay, and now we can find the voltage across resistor R1 because we have current I1 given and we found the resistance R1. We can find very easy voltage. In order to find voltage, I'm going to use Ohm's law. So V1 is equal I1 times R1, where I1 is equal 10 milliamps times R1 19.43 kiloohms. Okay, so this is equal 194.3 volts. Okay, so this is the voltage drop across resistor R1. Now we can find the voltage across resistors R2 and R3. Now we are going to use KVL, Kirchhoff voltage law, which says that voltage source is equal V1 plus V2, 3. Okay, so if you are going to solve this formula for voltage V2, 3, you will have voltage source minus voltage 1. So I have voltage source is equal 200 volts minus V1, which is equal 194.3 volts. Everything is equal 5.7 volts. Okay, so this is the voltage across this resistor. Other words, voltage across resistor R2 and voltage across resistor R3, because this is the parallel circuit. I mean, these two components are connected parallel. That's why voltage drop across each of these two resistors is the same. So I can say that V2, 3 is voltage 2, and this is also equal to voltage 3. So we found so far V1, and we found V2, and we found V3. Next we can find the current which goes through resistor R2 and current which goes through resistor R3. I'm going to use again Ohm's law. So I2 is equal V2 over R2, where V2 is equal 5.7 volts over R2, 900 ohms. Everything is equal 6.33 milliamps. Okay, so this is the current which goes through resistor R2. Next, I suppose to find the current which goes through resistor R3. So I3 I'm going to find from Ohm's law, so V3 over R3. V3 is equal 5.7 volts, okay, and R3 is equal 1.5 kiloohms. Everything is equal 3.8 milliamps. Okay, so this is the current which goes through resistor R3. If you want to verify your answers, you're supposed to add these two currents together, and you're supposed to get the value close to 10 milliamps. If the value is close to 10 milliamps, right, your answer is correct. If it's different, you have to verify your answers. Next, we can find the power at resistor R1. So I have P1 is equal I1 raised to the second power times R1, where I1 is equal 10 milliamps raised to the second power times R1, and we found that R1 is equal 19.43 kiloohms. So this is equal 1.94 watts. Okay, so this is power at resistor R1. Now we are going to find the power at resistor R2. So if P2 is equal I2 raised to the second power times R2, where we have I2 equals 6.33 milliamps, 6.33 milliamps raised to the second power times R2, and R2 is equal 900 ohms. Everything is equal 36.06 milliwatts. Okay, so this is the power at resistor R2. Next, we're supposed to find the power at resistor 3, which is equal I3 raised to the second power times R3, which is equal current which goes through resistor R3 is equal 3.8 milliamps raised to the second power times R3, which is equal 1.5 kilo ohms. This is equal 21.66 milliwatts. Okay, so we found all powers. Next, we're supposed to find total power. Okay, so this is the total power. Total power is equal I total raised to the second power times R total. So I have I total equals 10 milliamps raised to the second power times R total, which is given 20 kilo ohms. Everything is equal to watts. Okay? So what you're supposed to do next, you're supposed to verify if our answers are correct. I mean, you're supposed to make the calculation of P total again by adding P1, P2 and P3 together. Okay, so P1, P2 and P3 added together is supposed to give you value approximately 2 watts. I got 1.99 watts. So it means that whatever I did on the board is correct.